So welcome to this latest video on 162 Maths, and in this video we'll be going over the AQA Level 2 Certificate Further Maths paper of June 2022, paper 1, which is a non-calculator paper. Now before we get started working through this paper, a little reminder that in the description below I'll include a link to the paper and also include a question breakdown so you can see which question refers to which topic, and also include a link to the 162 Maths contents page which gives you easy access to lessons, topic tests, audits and exam papers covering the whole GCSE syllabus. So let's get started on question 1. So question 1 says x plus 1 is increased by 20%. Its value is now the same as x plus 6. Work out the value of x. Well, for this, whenever we are increasing something by 20%, what we do is we multiply that by 1.2. So what that means is 1.2 multiplied by x plus 1 is equal to x plus 6. So if I expand the brackets, I end up with 1.2x plus 1.2 equals x plus 6. Now this turns out to be a double-sided equation, so if I take the x over to the left-hand side and the 1.2 over to the other side, I end up with 0.2x equals 6 minus 1.2, which is 4.8. Then if I find the value of x, which is 4.8 divided by 0.2, and that's the same as 48 divided by 2, that gives me my final answer of 24. Moving on to question 2, it says the point minus 6 minus 4 lies on the straight line with a gradient of 3, 2. Work out the coordinates of the point where the line crosses the x-axis. Well, for this, if I use y equals mx plus c, and it doesn't really matter whether I'm using y minus y1 equals mx minus x1, I can use this here. So I know that when the gradient is 3 over 2, and I've also got an x and y coordinate, so these are my xy values, so x equals minus 6 and y equals minus 4. And the value that I'm looking for is the c. So substituting those numbers in, I end up with minus 4 equals 3 over 2 multiplied by 6 plus c. Well then, if I solve this and simplify this, that's going to be 18 over 2. So minus 4 equals 18 over 2 e plus c, and that's then going to give me a value of, what should be, minus 6. So let me just put that minus there, and from this we get minus 4 equals minus 9 plus c. So if I take the 9 over to this side, end up with positive 5 equals c. So that's going to give me a coordinate of 0, 5. Moving on to question 3, it says here we've got a function and we want to plot this function on the graph of y equals f of x. Now for this, what we've got, if I split the function up based on the range that I've got, so I've got one range of 0 to 1, so if I just put a rough dashed line at 1, the next range is at 1, 4, which is here, and the final range stops at 6. Now what I need to do is I need to plot these equations based upon the range that's given. So for here, when x is 0, that's going to be 4 minus 0, which is 4, and 4 minus 1, which is 3. So at 0, it's at 4, which is there, and at 1, it's at 3. So that's going to be a straight line going from there to there. Now again, you should be using a ruler. Then for looking at the next range, so this one here, I've got 4 possible numbers, which I'll do this here. Unfortunately, I haven't got a green pen, so let's just change this one for a green one. So when x is 1, I'm going to end up with 4 lots of 1 minus 1 squared, which is 4 minus 1, which is 3. So that's at that point there. When x equals 2, it's going to be 4 lots of 2 minus 2 squared, so that's going to be 8 minus 4, which is 2, so that's going to be there. And then at, oh, that's going to be 4, not 2, don't know what I'm doing there, so that should be 4, and that's going to be there. When x equals 3, I'm going to do 4 lots of 3 minus 9, so that's going to be 12 minus 9, which is 3. So that's going to be there. And when x equals 4, it's going to be 4 lots of 4 minus 16, which is 0. And that's going to be down here. So what that then becomes, if I join these points up, now recognizing this is going to be a quadratic or parabola. So I need to join those points up with a smoothish curve, and it should look something that looks like that. And then all that's left for me to then do is do the last one. Now this is going to be a linear equation. So here I've got 2x minus 8. So when x equals 4, that's going to be 2 lots of 4 minus 8, which is 0. So that's at that point there. When x equals 5, 2 lots of 5 minus 8 is going to equal 2. And so that's going to be there. And when x equals 6, 2 lots of 6 minus 8 is going to be 12, take away 8, which is 4. And that's going to be there. So all that's left for me to then do is join a straight line from there. So what that then looks like is it's going to look something like this. And again, make sure you're using a ruler with the 2 linear parts and a smooth curve for that middle part. For question 3b, it says g of x equals 6 minus 3x. Work out the value of the inverse function of g. So remember, for this we need to make it equal to y. And then we want to make x the subject. So I'm going to end up with y minus 6 equals minus 3x. And then y minus 6 divided by minus 3 equals x. And then from this, I've got my inverse function of x, which is y minus 6 divided by minus 3. Or you could write it as 6 minus y all over 3. So any of those two answers would be absolutely fine as your final answer. Moving on to question 4, it says A, circle the value of tan squared 30. So tan squared 30 is basically tan 30 squared, and tan 30 is 1 over root 3. So if we square that, we're going to get 1 squared, which is 1. Root 3 squared is just 3. So the one I want to circle is going to be 1/3. Then says 4b, on the axis sketch cos x. So for this, we just need to remember that cos x starts at 1. And then what happens is it looks something like that. So that should be at 1. So let me just draw that a little bit better. In fact, that it should look something like that. So looking at question 5, it says work out the values of a and b. So from this, what we need to do first is we need to expand the brackets on our left hand side. So if I just write that out, 3x plus a, 5x minus 4. So expand the brackets out, we end up with 15x squared minus 12x plus 5ax minus 4a. Then if I then write the right hand side, we've got 15x squared minus 2x plus b. So from this, what we then need to do is compare the coefficients. So if I look at the coefficients of x, on the left hand side we've got minus 12 plus 5a, so that's minus 12 plus 5a, and that equals minus 2. So from this I can then work out what a is. So 5a is going to equal 10, so a equals 2. And then if I then look at the coefficients of the constants, that's going to be minus 4a equals b. So minus 4a plus b. We know that a equals 2, so that's going to be minus 8 equals, sorry, I just don't know why I've put a plus there, equals b. And so that is there. And there I've got my second value. So a equals 2 and b equals minus 8. Moving on to question 6, it says y equals 2x to the power of 4, all multiplied by x cubed plus 2 minus 3 over x. And it says work out the value of dy dx. So the first thing I need to do here is expand the bracket. So here I've got y equals, and if I expand the brackets, I end up with 2x to the power of 7 plus 4x to the power of 4. And then 2x multiplied by 3 over x is going to give me 6x cubed. Then I can then differentiate. So remember, with the rules of differentiation, you move the power to the front and lower the power by 1. So that's going to be 7 times 2, which is 14, x to the power of 6 plus 16x to the power of 3 minus 18x to the power of 2. And there is my dy dx value. Moving on to question 7, it says ABC is a right angled triangle with vertices of A minus 1, 5, B minus 2, 5, and C minus 1, 5 and 3/4. And the question is asking us to work out the length of BC. Now, to work out the distance between two coordinates, I'm going to use this formula here. So it's y2 minus y1 squared plus x2 minus x1, and that's all square rooted, and that's a square there. So the two value coordinates I'm going to use is B and C. Now it's entirely up to you which order you want to do them. So for this, I'll use C as my second coordinate, B is my first coordinate. So the distance or the length is going to be 5 3/4 minus 5 squared plus minus 1 minus 2 squared. And then substituting that all in or simplifying it, that's going to end up with 3/4 squared minus plus, and then minus 1 minus 2 is going to give me 1 squared, and that's all square rooted, and so that's going to give me 9 over 16 plus 1, and if I change that 1 for 16 over 16, that's then going to be 25 over 16, all square rooted. Square root of 25 is 5, square root of 16 is 4, and there is my answer, 5 over 4. So moving on to question 8, it says use matrix multiplication to show that in the xy plane a rotation of 90 degrees anticlockwise about the origin followed by a reflection in the line y equals x is equivalent to a reflection in the x-axis. Now when attempting this question we need to do it in the reverse order. So here the reflection on y equals x matrix is going to be 0, 1, 1, 0. And the rotation anticlockwise from the origin has a matrix of 0, 1, minus 1, 0. So then doing the multiplication, what we then find is we've got 0, 1, 1, 0 multiplied by 0 minus 1, 1, 0. And if we do the multiplication, what we end up with is 1, 0, 0 minus 1, which lo and behold is a reflection on the x-axis. And there we go for that one. Now moving on to question 9, it says a quadratic sequence starts -2, -1, 4, 13. And the question is asking us to write down the expression for the nth term. So the first thing we want to do here is we want to find the double difference. So the difference from -2 to -1 is 1. Then we've got a difference of 5, and then we've got a difference of 9. So then if I then work out what the double difference is, that's going to be 4 and 4. So what's going to be in the formula is 2n squared. And it's going to be 2n squared plus the difference. So now if I work out my value of n, which is 1, 2, 3, 4, numbers in the sequence, which are -2, -1, 4 and 13. I know that 2n squared is in the formula, so if I just above just write the n squared numbers, so that's 1, 4, 9, 16, and so on. I double those, so double the purple numbers, that's going to be 2, 8, 18 and 32, and then all that's left for me to then do is then work out what the difference is going to be. So the difference between from here to here is going to be -4. Then it's difference between 8 and -1 is -9. Difference between 18 to 4 is 14 or -14, and then the difference from 32 to 13 is -19. Now as you can see, the difference values aren't the same, so then that's going to itself turn into a sequence. So here I've got a difference of minus 5. So as it's all the same, that's going to be a linear sequence, so it's minus 5n. And then what do I have to do to get from minus 5 to minus 4? Well, I need to add 1. So this is my sequence for the difference. So if I substitute that into my original nth term, I found that the nth term of this quadratic sequence is going to be 2n squared minus 5n plus 1. Moving on to question 9b, it says a different quadratic sequence has nth term of n squared plus 10n. Use an algebraic method to work out how many terms are in the space are less than 2000. It says do not use trial and improvement. So for this, what we need to do is we need to write this down. So we've got n squared plus 10n, and we want it so that it's less than 2000. So then if I take the 2000 over to the other side, it then turns into a quadratic equation. And then we can solve this by factorising, especially as is on a non-calculated paper. So I end up with n plus 50, n minus 40, and that's less than 0. And then solving this, we get n value of minus 50 or positive 40. Now with n representing the position of a term in a sequence, it can't be this. So then the correct answer must be 40. But then we need to remember that it's not going to be 40 because we want the values of where it's less than 0. So therefore n must equal 39. Because if we substitute 40, the 40th term, so that's going to be 40 squared plus 10 times 40. That's going to be 4 times 4, which is 1600, plus 400, that's going to equal 2000, and we want the terms where it's less than 2000, so that means that n is going to be 39. Moving on to question 10, it says rationalise and simplify fully root 3 over 3 plus root 3. So for this, to rationalise the denominator, I multiply by the denominator, reversing any sign that's in there. So I've got root 3 times 3. So if I just multiply up the numerators, I'm going to end up with 3 root 3 minus root 9 over, and then that's going to be, well, if you know you rationalise the denominators, that's going to be 9 minus root 9, which leaves me with 3 root 3 minus 3 over 9 minus 3, which is 3 root 3 minus 3 over 6. I can then cancel this down by dividing them by 3, so that's going to leave me with 2. That's going to leave me by 1, leaving with a final answer of root 3 minus 1, all divided by 2. Moving on to to question 11, it says expand and simplify fully, and we've got 3 plus 2x to the power of 5. Now there's a couple of ways in which you can do this. You can use by writing out the 5 brackets and multiplying, or you can use binomial expansion. Now with binomial expansion, we've got Pascal's number, we've got the first term, and we've got the second term. Now, as we haven't got a calculator, to work out Pascal's number, all I've got to do is this triangle. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and that is not, we're just going to do 1 extra, so 1, 5, 10, 10, 5 and 1, and that's the line that I need. So it's this here, so I've got 1, 5, 10, 10, 5 and 1. Now with the first term, that starts high, so that's going to be, the first term is 3, so that's 3 to the power of 5, 3 to the power of 4, 3 to the power of 3, 3 squared, 3, 1, 3, 0. And then the second term, that starts low, so that's going to be 2x to the power of 0, 2x to the power of 1, 2x squared, 2x, 3, 2x to the power of 4, and finally 2x to the power of 5. And what we want to do there is we want to multiply these to find the individual terms. Equals. So here we're going to end up with 1 times, now 3 to the power of 5 is going to be 343, and 2 to the power of 0 is just 1, so that leaves me with just 343. Multiplying the second one, I've got 5 times 3 to the power of 4 is 81 times 2x, and that's going to come up as 810x. For the next one, I've got 10 times 27 times 4x squared, and so multiplying them out I end up with 1080x squared. Then I'm going to end up with 10 times 9 times 8x cubed, and that's going to give me an answer of 720x cubed. And then finally 5 times 3 times, and that's going to be 16x to the power of 4, give me a total of 240x to the power of 4. And then finally 1 times 1 times, that's going to give me 32x to the power of 5, which is 32x5. Then all that's left for me to then do is then add these together, which gives me a final expression of 343 plus 810x plus 1080x squared plus 720x cubed plus 240x to the power of 4 plus 32x to the power of 5. And there we go. Moving on to question 12, it says the nth term of a sequence is 3n squared over n squared plus 2. One term in the sequence is 32 over 11. Work out the value of n. So for this, what we need to do is make the nth term equal, well, let me just write that a little bit better. N squared plus 2 is equal to 32 over 11. Then from this, what I'm going to do is I'm going to cross multiply. So we end up with 33n squared plus, or equals rather, 32n squared plus 2, which then equals 33n squared equals 32n squared plus 64. And then that then leaves me, if I simplify all of that, it's going to leave me with n squared minus 64 equals 0. This is a difference of two squares, so I've got n equals minus 8, n equals plus 8 equals 0, so n equals minus 8 or positive 8. Now as it's a sequence, n can't be negative, so n must equal 8. Moving on to the next one, it says write down the limiting value of the sequence as n tends to infinity. Well, if I write down the formula again, so it's 3n squared over n squared plus 2. Well, if n tends towards infinity, then what I'm going to be left with, well, the numerator is going to be 3 lots of infinity squared. So that's basically going to be 3 lots of infinity. And this is basically going to be infinity squared plus 2. Well, in theory, what's going to happen is the fact that this is just going to cancel with this, because the denominator rather, infinity plus 2 is basically the same as infinity, so the add 2 makes absolutely no significance when you're dealing with this. And so if this then becomes infinity, the infinities cancel out, leaving me with just a value of 3. Moving on to question 13, it says simplify fully, and we've got 6x cubed y to the power of minus 2 plus 9x to the power of 5y divided by 3x squared y to the power of minus 3. Well, if I write this out as a fraction, I end up with 6x cubed y minus 2 plus 9x 5y all over 3x squared y to the power of minus 5. Now what I'm going to do here is I'm just going to break this fraction up. So if we look at the numbers first, well, I can divide everything by 3, so that becomes 1, that becomes 2, that becomes 3. Looking at the x's, I can take the smallest power of x out, so I'm going to divide all the x's by 2, or take 2 away, so that then becomes a 1. That's then going to become a 3. Now when it comes to the y's, well, I'm going to end up with y minus 2 over y minus 3 plus, and then we've got y 1 over y to the power of minus 3. Now if I simplify this, this is going to become y1, and this is going to be y to the power of 4. So then from this then, what we end up with is 2x y plus 3x cubed y 4. And there is my final answer for that one. Moving on to question 14, it says rearrange EF equals 5e plus 4 over 3 to make E the subject. Well, for this, what we need to do is first of all take the 3 over to the other side. So we end up with 3EF equals 5e plus 4. Then if I take this over to the other side, I end up with 3EF minus 5e equals 4. Factorise with respect to e, I end up with 3f minus 5 equals 4, and then take this bracket over to the other side, leaving me with e equals 4 over 3f minus 5. Now moving on to question 15, it says B, C, D are points on a circle with a centre of P. AB and AC are tangents to the circle, and the question is asking us to prove that y equals 90 plus x over 2. So for this, if I take BC and I just drag it down, let's say here, so this is my new B, this is my new C, then what that then becomes is this then becomes an arrowhead, which therefore means that this angle here is going to be half the size of that angle there. So if I then take the shape of DBPC as an arrowhead, then what that then means is that this angle here is going to be 2y. Now if that's 2y, then this angle here is going to be 360 minus 2y. Then from the shape, if we know that AB is a tangent, then that means that a radius meets a tangent at 90 degrees. And because we know that P is the centre, the line PB is going to be the radius. So then taking this shape, now if I just draw out, again, a really rough sketch, that this is 90, this is 90, this is x, and this angle here is 360 minus 2y, then we know that all of those four angles add up to 360 because it's quadrilateral. So I've got x plus 90 plus 90 plus 360 minus 2y is equal to 360. Well, this becomes 180. So if I take that to the other side, I end up with x plus 360 minus 2y equals 180. Then taking the brackets out, x plus 360 minus 2y equals 180. And then what I want to try and do from here is make y the subject. So if I take the y over to the other side, I end up with x plus 360 equals 180 plus 2y. Then take the 180 over to the other side, so I end up with x plus 180 equals 2y. And then divide everything by 2. So x over 2 plus 180 divided by 2 equals y. And then if I simplify that second fraction, I end up with exactly what they wanted me to prove. Now moving on to question 16, it says solve the simultaneous equation, and it says we can't use trial and improvement, not that we would anyway. So for this, if we look at the linear equation, which is this first one here, if we make one of the letters the subject, so let's make x the subject, so I end up with 19 over 4 plus y. And what I'm going to do is I'm going to substitute this way into x with the non-linear equation. So here, rather than writing x, I'm going to write 19 over 4 plus y multiplied by y, and that equals minus 3. Then if I expand the brackets, I end up with 19y over 4 plus y squared equals minus 3. Then if I multiply everything by 4, I end up with 19y plus 4y squared equals minus 12. Then from this, if I then turn this into a quadratic equation, I end up with 4y squared plus 19y plus 12 equals 0. Now unfortunately that doesn't cancel down, so what I would then need to do is then think to factorize this, and it does factorize into 4y minus 3 and y minus 4 equals 0, and therefore solving that gives me a y value of 3 over 4 or positive 4. So then when y equals 3 over 4, and using the nonlinear expression of, or I could actually use either, so let's go for xy equals minus 3, what we end up with is x and then 3 over 4 equals 3. Take the 4 over, so 3x equals minus 12. And so x is going to equal minus 4. So that's one set of equations, one set of values. So x equals minus 4, y equals 3/4. And then substituting the second value of, so then using our second value, so when y equals 4, we're using xy equals minus 3 again. So here I'm going to end up with 4x equals minus 3, so x is going to equal minus 3/4. So there is my second coordinate. So when x equals minus 3 over 4, y equals 4. And there are my two sets of coordinates. Moving on to our next question. We've got the point P lies on the circle of x squared plus y squared equals 16. The line OP is on at an angle of 60 degrees to the positive x-axis. Show that the coordinates of P is 2 and 2 root 3. So for this, if we start by first of all drawing a triangle. So here we've got O, here we've got P, and we've got 4. And we know, and the reason why I've got 4 is because from the equation of the circle we know that the radius equals 4. So that means that this length here is going to be 4. Now if I want to work out what the y ordinate is, and this is 60, so I then use sine 60 equals y over 4. Now sine 60 is the exact value of trig, so that's root 3 over 2 equals y over 4. Then doing a bit of cross multiplying or taking the 4 over, I end up with a y value of 2 root 3. Then if I work out the same triangle, so this is 60, this is 4, and I want to work out what the x coordinate is. This time I need to use cos 60 equals, and that's going to be x over 4. Cos 60, another exact value of trig, so I've got half equals x over 4. Do a bit of cross multiplying and I get x equals 2. So my x ordinate, so P, is going to be at 2 root 3, which is exactly what they wanted me to show. Moving on to 17b, it says work out the equation of the tangent to the circle at P. Write your answer in the form of x plus ay equals b, where a and b are constants. So the first thing we need to do is first of all work out the gradient of OP, which is the distance up divided by distance across, so that's going to be 2 root 3 over 2, which leaves me with a gradient value of root 3. So therefore the gradient of the tangent is going to be the negative reciprocal of minus 1 over root 3. Then using y minus y1 equals mx minus x1, I know that I'm going to use the coordinate of x equals 2 and y equals 2 root 3 and m equals minus 1 over root 3. Substituting that all in, I get y minus 2 root 3 equals minus 1 over root 3 x minus 2. Then if I multiply everything by root 3, I'm going to end up with root 3y minus 6, because that's going to be 2 times 3, equals minus 1 x minus 2. And then from this, I can then simplify to give me an answer of root 3y minus 6 equals minus x plus 2, leaving with a final answer of root 3y plus x equals 8. And there is my answer. Now moving on to question 18, it says in the triangle RST, it says RS to ST is in the ratio of 1 to 4. So what that means is that if SR or RS is x, then ST is going to be 4x. And once I've got into that formation, I can then use the sine rule to then work out what sine theta is going to be. So using the sine rule, what I end up with is 4x over sine of 135 is equal to x over sine theta. Then from this, if I quickly do a quick sketch of the sine curve, that at 135, that's the same value of sine 45. So sine 135 is equal to sine 45. And if sine 45 is 1 over root 2, then so is sine 135. So what we've got here then is 4x. If I do a bit of cross multiplying, sine theta equals x sine 135. Now we know, as I've just mentioned, that sine 135 is equal to 1 over root 2. So 4x sine theta equals x multiplied by 1 over root 2. Then if I take the 4x over to this side, I end up with sine theta equals x multiplied by 1 over root 2, and that's going to be multiplied by 1 over 4x, which combined gives me x over 4x root 2. The x cancels out, in which then all I'm left with is 1 over 4 root 2, which if I can leave my answer like this, so sine theta equals 1 over 4 root 2. But if I wanted to rationalize the denominator, so let's just see what that would give me. Then that would give me 4 root 2 at the top, and that would give me 16 times 2, so that's 32. So 4 root 2 over 32. That then cancels down to an eighth, so it'd be root 2 over 8. So again, two possible results you can have for this, and both of them would be absolutely fine. Moving on to question 19, it says write 6x squared minus 24x plus 17 in the form of a lots of x plus b all squared plus c, where a, b and c are integers. So in other words, what we need to use is completing the square. So if we have 6x squared minus 24x plus 17, well, the first thing I need to do is get x squared out. So if I factorize this with respect to 6, I end up with x squared minus 24x over 6 plus 17 over 6. Now this becomes 4x. So what that then becomes is 6x squared minus 4x plus 17 over 6. And then what I can then do is use completing the square for my square brackets. So 6, and then I've got x minus 2 squared plus 17 over 6 minus 4. Then if I can rewrite 4 as a fraction with 6, that's going to be 24 over 6. And the reason for that is just so I can combine 17 over 6 minus 24 over 6. So 6 lots of x minus 2 squared plus 17 minus 24 all over 6. And if I take that to the side because I've run out of space, I've got 6 lots of x minus 2 squared plus, well, it's actually going to be minus, which I've already done. So that's going to be minus 17 take away 24 is going to leave me with 7. So that's 7 over 6. And then multiplying the 6 out, I get 6 lots of x minus 2 squared minus 7. And there is my final answer for that one. So moving on to question 20, it says the curve y equals x to the power 4 minus 18x squared has 3 stationary points. Work out the coordinates of the 3 stationary points and determine their nature. And you must show you're working out for 6 marks. Well, the first thing to recognise is that at stationary points, dy over dx is going to equal 0. So first of all, finding out what dy over dx is. And that's going to be, and again, remembering the rule of differentiation, move the power to the front and lower the power by 1. So that's going to be 4x cubed minus 36x, and then from this we made that equal to 0, and this is what we then need to solve. I'm going to solve this by using factorisation. So if we take 4x out, we're going to get x squared minus 9, and then what we can then, well, hopefully what you've spotted there, that this is going to be a difference of 2 squares. So here we've got 4x, and then it's going to be x minus 3, x plus 3. And from this, what you can then find is your 3 values of x where it equals 0. So the solutions for this is going to be x equals 0 or positive 3 or minus 3. Then from this, what we then need to do is find the respective y ordinates. So using y equals, and if we go back, we can see the equation just about on the screen. That's 4x to the 4 minus 18x squared. So when x equals 0, substituting x equals 0 into this, we're going to get y equals 0. So one coordinate is 0, 0. When x equals positive 3, I'm going to get 3 to the power of 4 minus 18 lots of 9, and that's going to give me a value of minus 81. So the other coordinate is going to be 3 minus 81, and then when x equals minus 3, well, the substitution is going to be the same because we've got even powers, so that's also going to give me a y value of minus 81. So that coordinate there is minus 3 minus 81. Now all that's left for us to do is to find the nature of those. So to find the nature of the stationary point, well, when we find the second derivative, if it's less than 0, it's going to be a maximum point. If it's greater than 0, it's going to be a minimum, and if on the off chance it's equal to 0, then it's going to be a point of inflection. So for this, if we substitute the values, so when x equals 0, then we'll need to work out the second derivative first. So the second derivative using dy dx, which is this here, is going to be 12x squared minus 36. So when I substitute x equals 0 into the second derivative, that's going to give me a value of minus 36, which is less than 0, so that's going to be a maximum point. When x is equal to positive 3, then the second derivative, I substitute x equals 3, is going to be 12 times 9 minus 36. Well, that's going to be a number that's greater than 0, so that's going to be a minimum. And for the final point of minus 3, then if I substitute, that's going to be 12 minus 3 squared minus 36. That's also going to be greater than 0, so that's also going to be a minimum. So all that's left for me to then do is write that all down. So here, one stationary point, we've got 0, 0, and that produces a maximum point. And when we've got minus 3 minus 81, that's a minimum point. And when it's positive 3 minus 81, it's also a minimum point. So moving on to our last question, question 21, it says show that 4 cos squared x plus 3 sine squared x minus 4 all divided by cos squared x equals minus tan squared x. Now for this, what we want to try and do is recognise that to get tan squared x we need that's going to be equal to sine squared x over cos squared x. Now we can ignore the negative for the time being, but that's basically what I'm aiming for. Now at the top on the numerator you can see I've got a mixture of cos squared and sine squared. So if I take the trig identity of the cos squared x plus sine squared x equals 1, and I make cos squared x the subject, we get this. Or I can have that cos squared x equals 1 minus sine squared x. Now from this, as I want to try and make the numerator to have sine squared x, I'm going to use this substitution and substitute that into my numerator. So what I'd end up with is 4. Now instead of writing cos squared x, I'm going to write 1 minus sine squared x plus 3 sine squared x minus 4 all over cos squared x, and this is where I'm working with the left hand side. So then if I then simplify the numerator, I'm going to get 4 minus 4 sine squared x plus 3 sine squared x minus 4 all divided by cos squared x. Then if I simplify the numerator, well, 4 minus 4 cancels out, in which then I've got minus 4 plus 3 sine squared x, which is going to leave me with minus sine squared x over cos squared x, which lo and behold equals minus tan squared x, which equals which is basically what they wanted me to show. And there we go.